Hello, good day. My name is Parag, and this is our third year electromechanical engineering project at Humber. Our group is called Blow Mold Cutoff. As you can see, we're in partnership with ABC Technologies and Duquesne Intelligent Assembly Solutions. My group members are David G, who's in charge of mechanical.
That's me.
This is David Ho, who's in charge of robot programming and HMI programming.
Hello.
And this is Derrick Lee, who's in charge of PLC and vision system.
Hello.
So I'll give you a little breakdown of our cell. Basically, our cell, just come over here. Our cell is ultrasonic cutting. We've been assigned from ABC Plastics. They have some blow molded parts, and the domes at the end of the blow molded parts are left on, as you can see on this part. We cut the parts in half because of the limitations of the space. And our assignment was to get for them to cut off the domes with that's very clean, no chipping, no burring. So since this is a proof of concept, our simulation will not cut the domes, but will just show that we're able to obtain clean cuts with the ultrasonic cutter. So we're going to step you through it. David Ho will start the sequence, and you will see the right side cut first, and then you'll see the left side cut first. So we'll just start and show you.
All right. So for the right side.
Yeah, it's working. Can you see the thing? I know that. You put something here. Everything doesn't come out. If it's not, it doesn't come out. I have a program.
Hard to see. Yeah, it's too hard to see.
It's fine, this one.
This one's got great stabilization.
Just to note that the cuts are consistent, but sometimes it would be off a few millimeters or a little too deep because just the orientation of this part is very complex, and we weren't able to get the CAD file. So we did our best what we can with the limitations that we had. So sometimes we'll see the cutter cut deeper than some, but yeah. Right now, if you look at the HMI screen, it says we're on side 3 because this is the 3rd side. We had to program it like this because we're not able to maneuver the robot because of the size of it all the way around at once. So we did it side by side using a 4-bit signal using the robot's I/O. There's also a vision system that will, if this was working perfectly, would be to check if the cut left any burrs or not on the plastic part. But this vision system will just check if the part is in the gripper. Yeah, so now we're on cut 4. As you can see, there's just a device status there will turn green when the sensor or bit is activated, and red when it's not. Those points you have to adjust. Everything does. So here's where it goes to do the vision check. It's just checking for the part right now because the cuts aren't perfect because of the limitations, like I said, that we've had. And there's the Omron camera taking a picture saying it's okay because its range is set correctly. So this is the final drop off, and what I'll do is I'll take out the part so you guys can see the cut. And then we're gonna put the left side. The left side is slightly different. It just cuts 5 straight lines in a row, just to show that the cutter can cut straight lines repeatedly. All right, so I'll take out this. So as you can see, the cutter did a fairly good job. I know there's a little bit of melting here, but that's because just the irregular shape that we have on how the gripper is cutting through it. That was a really good cut. We hardly left any burrs at the end of it, and that's what we were trying to have. This one a little more because it went in a little too deep, but this is just a proof of concept, like I said before, and it does do what we said. So right now we're going to show you the left side, which will probably give us better cuts because we picked the best gripping angle for the part. So it should really provide us with clean, good cuts. And it just started. This will be the best cut. Like, right a little bit. As you can see, this is a better cut because just how we're gripping the part. Pick the best possible angle. This is a 20,000 hertz, 20 kilohertz, 20,000 hertz ultrasonic cutter, and this was the best solution that they found to cutting these parts from Duquesne. And it's all loaned to us because they believe that the technology works for plastic, and we're trying to prove that also. So that was the last cut for that side. As you can see, those cuts turned out better. Just give me 1 second and I'll show you what they look like close up. So like I said, if this cutter was done in an ideal way, it would be attached to the robot, so I have better movement, more mobility. Same thing. And the process would be 10 times faster. So, there we are. As you can see, much cleaner cuts, and that's what we're looking for. So thank you for watching the video, and bye.